So we're going to start this video just by quickly recapping excitation by photon absorption and putting in one fact we didn't have. So we were saying about how our electrons can only absorb certain frequencies of light corresponding to the difference in energy levels. We can actually write down what those are. So let's take this example. If we're originally in a shell with energy E1 and we move to a shell with energy E2, then we can see that the energy of the photon we absorb has to be exactly equal to the difference. So the energy of our photon absorbed, the only energy of a photon we're allowed to absorb, it can't have more than that or can't have less than that unless we're going to transition all the way up to this level, is just equal to the difference in energy between those levels, which is equal to delta E, which is going to be E2, which is the level we moved to, minus E1, which is the level we're originally at. So HF, whatever is the frequency of our photon, is equal to E2 minus E1. And that's the equation for the frequency of the photon we're allowed to absorb. That's it. So whatever, you're basically allowed to absorb whatever frequencies correspond to these. So if whatever E2 you've got, minusing off the original energy you're at, you're allowed to absorb a photon with this frequency. If that frequency doesn't exist from this equation, if you can't find an energy level you could put in such that that would give you that frequency, then you can't absorb that frequency and that'll pass through your atom. So if E1 is the energy of your original shell and E2 is the available higher energy shell, then HF is your allowed absorption frequency. So what this could also mean is that E1 is the original state you're in. So E1 is the original energy level of your atom. Say it could be your ground state, or it could be your first excited state, wherever you start. And then E2 is an available higher energy shell or a possible excited state. That is to say that it's whatever you're not currently in. It could be up here, it could be up here. Whatever excited state exists that you're not currently in, then that is an allowable frequency you can absorb. You're allowed to absorb a frequency that obeys this equation. If that's not the case, then you can't absorb that frequency. That matters because now when we look at, de-excitation and photon emission, what we see is that however we get there, whether by collision or by absorbing photons, etc., excited states are unstable. They're always unstable because there's a lower energy state available to the atom that it would prefer to be in. That's because an electron moving to an outer shell, which is how we excite something, our atom is excited because an electron's gone to a higher energy shell, that just leaves a vacancy in the lower energy shell left behind. So for instance, in our excited state of hydrogen, this is its first excited state. This is its first excited state corresponding to this electron having moved up to this higher energy level. Then what can actually happen is it can drop back down. It can be filled by another electron. In the case of hydrogen, it's all we've only got one electron, so it's going to be the same electron. It can be filled by another electron from a outer shell, transferring to it by emitting a photon.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level physics videos, just click the Snap Revise smiley face. Join me today, and together let's make A-level physics a walk in the park.